Ready, go. Launching in 5, 4, 3, 2, 1, 0. That's what we want to see. Textbook.
Hey folks, Nathan here. I'm incredibly happy to say that our parachute system is now considered to be flight ready. While there was some success earlier in the project, I wanted to reach the goal of having 3 successful deployments and landings in a row before saying that this stretch was finished. And that goal has finally been reached. So with this video, first off, I'll go into the parachute deployment system in depth, talking about the pros and cons of the system and sharing the code that was used. Next up, we'll look at all 8 launches that got us to this point from the previous Hydron version. And lastly, we'll do our analysis, going over all the failures and how they were overcome. So let's dive into it. In an earlier video, I explained how the parachute itself was built, and that hasn't really changed throughout the duration of the Hydron project, so I'm not going to go into that here. What I will say is that a bit of testing was done to figure out the best way to actually pack the parachute into the nose cone, because we did have one failure early on in our launch systems where the parachute got stuck inside the nose cone on deployment, and another one where it just didn't unravel properly. So we spent a bit of time figuring out how to get that to go right. Cool, so let's dive into the actual deployment mechanism itself. So our electronic setup is incredibly simple. We have our Arduino Nano right here. We have an LED. We have a broken LED from a previous attempt. We have a button which starts off our countdown. We have a BMP280, which we never got to work. And then over here we have our 9-volt battery case and our servo motor. The deployment system itself works pretty easily. Inside we can see our circuitry. It's important that our servo motor is located right here. So what will happen is we'll stuff our parachute up top here into this. Then this will come up and around. The nose cone will come up here, and then this bit of elastic, which is just a hair tie, will tie around the servo motor. So you can see there, our elastic goes from the servo motor up to the nose cone, and then on the back side we have this much firmer elastic band, which is attached to the very tip, and that comes all the way down to this super glued section here, and that's always putting pressure on the nose cone here. So the moment that the servo motor goes off, an example here, so the servo motor will move up, it'll release this band here, and then this rubber band will pull the nose cone off, and that will also, the force of the nose cone coming off will cause the parachute to fly out. And that's all that the parachute deployment system is. It's, yeah, super simple, it's pretty reliable, and yeah. So with the explanation of the parachute deployment system done, let's go over the code on how it actually works. So we use the servo.h library. We have our servo here, we just call myservo. We've got the current state, so for this we use a state machine. Essentially it runs different bits of code depending on what our state is, and I'll explain what our different states are later. We have the readout pin. So in this case, this is our LED, which is letting us know the current state of the launch. We really just use this for the countdown in this program. We have the reset pin, which is what we use to initialize our countdown. That's just our button. And yeah. In our setup, we do serial begin, just in case we need to do any serial monitoring. We define our pins. Then we start out with our readout pin on high, so our LED is lit up. And we set our servo up and we make sure that it's in the correct position. So now our loop. So our state machine here, we have state 0, it's idle on the launch pad. So this is when it's just sitting there waiting for us to start the countdown. State 1, it's counting down to launch. So this is doing our 5-second delay, and then 5-second countdown followed by 3 seconds and then launch parachute. Then state 2 is our parachute deploy, where the parachute actually deploys. And then all we have here is a switch case, so for the state, case 0 it's idle, case 1 countdown, case 2 deploy. Pretty simple. Alright, our idle state. While we're waiting on the launch pad, our light is on and we're waiting for the countdown. And then when the digital read pin comes in, which means that our button's been tapped, we move to state 1, which as we set up here is our countdown state. So our countdown state, our light goes off for 5 seconds. So the reason that we have this is so that we press our button, we then get to a safe distance, ready to use our pull string before the actual countdown itself starts. Then we have a for loop with just a 5-second countdown. The readout pin or our LED will flash on for 200 milliseconds and then off for 800 milliseconds. So this gives us a 5-second countdown. And then once our countdown's done, our pin goes on, so our LED will be on. And when that final LED comes on, we know that it's time to pull and begin our launch. And then finally, we set our state to 2, which is our deploy state. And with our deploy state, we wait 2.7 seconds. We set our servo to the up position, which deploys our parachute. We then wait 1 second and we return our servo back to the original position and we go back to idle state. So the reason that 2.7 seconds was chosen is because the rocket goes on a 5 to 5.5 second flight from all the way up to all the way down if you don't have a parachute. So we picked a time that's roughly halfway in there, so pretty reliably this deploys either on apogee or just after apogee, and it works pretty well. Now that you know everything about the Hydron's parachute deployment mechanism, let's go over the pros and cons of the system. So the pros, it's incredibly simple, it's only a few components, and it's really easy to troubleshoot because it's only a few components. And there's not really any advanced knowledge required because it's only a few components. It's very reliable, so once it's set up, it's pretty hard for it to fail. It's definitely possible for it to fail, don't get me wrong, but it's largely a result of other structural elements and not the deployment system itself. And thirdly, it's cheap. So all you need is a nano, a servo, an LED, and a button, and you're basically good to go. The most expensive part is the nano, and depending on where you are in the world, that's going to be pretty cheap. So the cons. The big one is that there's no ability to abort. So the moment a countdown starts, the parachute's going to deploy in 12.7 seconds, whether you like it or not. The only thing you can do is try and get to the rocket and turn the 9-volt battery off. But unfortunately, if you've got a pressurized rocket on the launch pad, that could be a dangerous situation, so obviously that's something you're going to want to avoid. Problem number 2, the values are hard-coded, and you can't change the values on site. So a lot of flight computers you find will have the ability to go into a programming mode essentially, where you can just hit a couple of buttons to change the timing values and whatnot. This doesn't have that because we're mainly building a parachute deployment system and not an actual flight computer yet. But if you do want to build a system like this, I'd advise putting in a bit of programming in there just so that if you are on site and the situation changes, you need a slightly later or a slightly earlier parachute deploy, you can do that. And the third is some construction issues. So once again, not related to the deployment system itself, but bad construction can lead to a bad deployment. So the elastic can put a bit of force on the servo, and as you can see here, poor construction methods mean that the Velcro could separate at any moment, which could lead to an early deployment. Luckily, we didn't have this happen at all. The Velcro managed to hang on, but I was pretty worried a couple of times that it was just going to rip off and my parachute would deploy halfway through the air. Okay, it's time for the exciting part, our launches.
Press that button and then okay. Launching in 5, 4, 3, 2, 1. Beautiful. You work. Okay, launch number 2 of the Hydron VO.6. Let's just chuck it on. Okay. Launching in 5, 4, 3, 2, 1, 3. Oh, no dice on that one.
This launch was recorded in slow motion, so rather than sit through the entire 2.5 minute slow-mo video, I've sped it up for this, muted the audio, and we'll look at some of the slow-mo in the analysis section.
Start launch number 1. Launching in 5, 4, 3, 2, 1, 0. Nifty. And visualize. Launch number 2 going in 5, 4, 3, 2, 1. Oh no, not again. Alright. Ready, go. Launching in 5, 4, 3, 2, 1, 0. That's what we want to see. Textbook.
Launch number 7 was another one that we did in slow motion, so as with launch 3, we'll speed it up, mute the audio, and cover some slow-mo stuff later.
Final launch. We initialize. Okay. Launching in 5, 4, 3, 2, 1, go. And there we go, 3 in a row. Oh. Thing of beauty. We lost the fin on the crash, but I think it's fine.
Well, that was a lot of launches. We had a few different things go wrong over the course of Hydron V0.6, so let's kick off with launch number 1. So launch 1 was actually flawless. That one went about as well as we could have expected, and the dream was that we'd have another 2 launches just like that. And as I'm sure you can guess, that didn't happen. Launch number 2. So launch 2 ended in failure, unfortunately. It appears that the servo just straight up didn't deploy. We're not sure whether this is a problem between the timing mechanism or if there was a loose connection somewhere on the board, but after crashing, the board itself wouldn't turn on, so it's a pretty good chance that there may have been something wrong with the circuit. We went hunting on the circuit board with a multimeter to try and find which connections were and weren't still working, and the ones that weren't we managed to resolder, and the circuit seemed to work pretty fine after that, despite all the pins on the Nano being all wonky. Hey, moving on to launch number 3. So with launch 3, our servo did deploy on the way down, so big plus there, but unfortunately our parachute got caught in the nose cone. So the old nose cone which had broken, it had this lip here, which you may be able to see, maybe not. But if I hold it like that, it'll be a bit easier. You can see on this side here, where that's sort of folded in. And I'm pretty sure that the parachute managed to essentially get caught on that, and that just held it inside the nose cone. It wasn't able to fly out because whenever it did, this lip here would just stop it. And so it sat snugly in the nose cone the entire way down and resulted in a crash. This was fixed by essentially just getting a new nose cone. Both launches 4 and 5 were affected by the same issue. This one was to do with the way our parachute was attached to our rocket. So our parachute has 8 different cords on it, and then these cords all come into a central point where we just have a bunch of masking tape around it. That sort of comes out, another bit of masking tape on the other end, and then one of those 8 cords came out and attached to the top of our rocket. So what was happening was the masking tape had come loose, and when the rocket was under gravity, the parachute would basically have a whole heap of drag, but the gravity of the rocket was stronger, so the rocket pulled down. It pulled this one single cord down, and we can see that one side of the parachute just being pulled down towards the rocket, and that just compromised the entire stability of the parachute, and it just sort of spiraled down to the ground. So in order to fix this, we had to rework how our shroud lines were working. So rather than having the single line going from the parachute all the way down to the rocket, what we did was we still have our single cord attached to the rocket here, but down in this section, rather than this line being attached all the way down to this parachute, we cut the line, we doubled the cord here back on itself and wrapped it up very heavily in masking tape, and we basically just put this through that loop and tied a knot. So now no matter how hard we pull on this, it's not going to affect the greater parachute because it's not actually attached to the parachute and it's pulling all 8 lines simultaneously. And that brings us to launches 6, 7 and 8. So all these launches were considered successes. Launch number 8 at the end did lose a fin, but the rocket had been broken and repaired so many times at that point that as far as I'm concerned it was on the way out anyway. So yeah, those last 3 launches gave us our 3 launches in a row that we needed to finish off the project. So I think my biggest takeaway from this part of the project has been that pretty much up until very recently, my mindset going into this has been not ideal at all. So what I mean by that is that I've been very impatient. Because of that, I've been taking risks that I shouldn't have been. I've been launching when it was windier than it should have been, so there's been parachute failures in the past because of that. I've been testing things on the launch pad, and with Launch 3, for example, as you can see just here, on the launch pad test, the parachute didn't deploy properly, and I was just like, alright, I really want to get this in the air, so I'm just going to assume that it's going to fly properly, and the air rushing past it will deploy the parachute. Obviously that didn't happen, and it led to a crash, and there was time and money wasted because of that, and that's definitely not the first time it's happened, but I am hoping that this part of the project will be the last time that it happens. Because, like, as a hobby right now, it's not too bad, but eventually I would love to get into, like, commercial rocketry, and that's not a mindset you can really have for commercial rocketry. You can't just assume that if something hasn't worked in testing that it'll work live, because it's almost a guarantee that it won't. So yeah, I think my biggest realization in this project is that my mindset has had to change, and I've started doing that. Definitely launches 6 through 8 I had that kind of mindset in there, but yeah, it's going to be a process, so we'll see how that goes. So, next steps. I think the biggest thing that I'll be doing is retiring the Hydron and calling this latest version of the Hydron 1.0. Through this project, I've learnt the basics of rocketry, aerodynamics, and electronics, and we've managed to build a small rocket for a total cost of about $50 that can reach a decent altitude and land safely. So, just because the Hydron's retiring, that doesn't mean that this is the end of my water rocket projects. So the Hydron itself is pretty much in a state of disrepair, which is a large part of the reason that it's being retired. We've got one fin left. It's covered in old bits of balsa wood and super glue and masking tape. Most of our cardboard is just falling off. Our circuitry is just completely separate now. So yeah, it's time for something new. So what I'll be doing is creating a brand new project with everything that I've learned from the Hydron. This is going to be a new water rocket that I'll be calling the Aquarion, and it's planned to have at least twice the fuel capacity as the Hydron, and it's going to be used as a testbed for more advanced electronics and hopefully some actual science experiments. So with that, I hope you've all enjoyed this journey, and I'm looking forward to starting the next one and even further expanding my knowledge of rocketry. I'm not sure how long it'll be until the next video is up with our first Aquarion episode, but hopefully it shouldn't be too long. I look forward to seeing you all then. Catch you later.